64 Visualization Final Project Presentation. I'm Jyothi Koushik Paladugu.
And I'm Kushaal Rana.
The title of our project is Visual Analytics on Unemployment Trends in California. We are going to present a visual dashboard. So, starting with the introduction and the inspiration for this project, California is one of those states which has consistently maintained a high unemployment rate. It always consistently hold the top three spots for every year starting from 2008 until 2024. Even in this year, as of May 2024, California is the state with the highest unemployment rate, that is 5.3% according to Forbes. This case particularly interested us because the consistency of the high unemployment rate is something that we wanted to investigate and deal with using the help of visualization.
Okay, so now I'll tell you about dataset which we used. So the dataset is collected from the State Department of California database and also from the website, and also we used website like data.gov, uh, and we fused these two dataset to give us the final dataset. Also, these dataset contains 14 attributes which covers extensively 58 counties of states from year 2008 to 2021. All these attributes are analyzed to draw the important relationships, patterns, and conclusions for this problem, that is unemployment trends.
Okay, let us now dive into the dashboard. So as you can see, this is our visual dashboard which focuses on the unemployment trends in California. There are 5 visualizations. Let me take you one by one. The first one is the slider, which is for the year. So the data set contains years from 2008 to 2021. So changing this slider would update certain visualizations, particularly the choropleth and the correlation heat map. We have got two attributes to select for the scatter plot and also to update all the visualizations via linked brushing. Let us dive into the visualizations one by one. Starting with the choropleth map, this is a geomap containing the state of California subdivided into the counties. California has got 58 counties, hence you can see when you hover over a specific county, it is going to show the name of the county and the value of the particular attribute that you have selected. The first sliding bar, the drop down menu that you see, that is the attribute that is selected for the choropleth. This is a very useful visualization tool to study the trends of an attribute across all the counties across all the years. One of the insights that we gain from the choropleth map is the high unemployment rate in Imperial County over the years. Starting from 2008, when you go to 2015, the unemployment rate is still the highest, and up till to the latest data, that is 2021. So Imperial County consistently maintained the highest unemployment rate, and as we investigated this matter, we found out that the education training that is given to the people in the Imperial County is very less, and almost 46% of the people are uneducated, which is accounting for the high unemployment rate. This is one of the insights that we have gained. Second is the time series chart as seen below. This one visualization is very useful to discuss the time pattern trends from for an attribute and for a specific county. The default county is Alameda, and we have selected the unemployment rate, so we can see the trend of the unemployment rate in the county from 2008 to 2021. You can select the county from the choropleth map or from the radial chart. When you select a specific county from the choropleth, the time series chart automatically updates via brushing. One of the peculiar cases we have seen here was the high unemployment rate change in certain counties such as Alameda, San Mateo, and Santa Clara. The rate of increase in the unemployment rate from 2019 to 2020 was the highest in these counties, which followed a geographical pattern. It is even more higher than Imperial County, which holds the highest unemployment rate. So our investigation found out the fact that all these counties have a specific geographical pattern, which is all of these come under the Silicon Valley, which is a front fold for all the tech and the finance industries. So when the recession hit in 2008 and immediately after the COVID pandemic 2019, the tech, finance, and the construction companies were the first to see all the recession and the job loss. So, which is why there was a significant and an unusual increase for all these counties compared to the other counties. So, this is one significant insight that we could gain from the time series chart. And coming to the coming to the correlation heat map, this one is a very useful visualization to study the relationships between all the attributes subdivided into a matrix. So when you hover over a specific element in the grid, you see the correlation value and the attribute X and the attribute Y. Both the choropleth and the correlation have the color legends starting from the lighter to the darker ranges and also the labels. The correlation value ranges from -1 to 1, where 0 is for uncorrelation. So one of the peculiar trends we have found here is the correlation between the unemployment rate and the expenditures per capita, which should be highly negatively correlated, but it is not that we expected. One of the studies found out that a weekly unemployment benefit of $450 given in the state of California for the unemployment people was one of the main reasons for not much decrease in the unemployment rate, which explains the correlation here. So this is one useful insight that we were able to gain from the correlation heat map.
Okay, so I'll explain about the scatter plot matrix, scatter plot, and the radial chart. So as we know, the scatter plot gives us the relation between the two attributes. So here we have two attributes called the average weekly wage and the unemployment rate. So the way interactions work here is, if we set we have this drop downs over here, so we can select any drop down and it would update the scatter plot, and we can change the y-axis. So this is how it updates the scatter plot, and in order to update the radar plot also, we can choose whichever attribute and it will update the radar plot accordingly. So now let me show you what the scatter plot determines. So let me first select one attribute, that is establishment, and another attribute, that is the unemployment rate. So let's now analyze this scatter plot. So as we can see that there are, like, this scatter plot is negatively correlated. That means the unemployment rate and the establishment are negatively correlated. So here we can see that the majority of the data points are clustered in the lower left region of the plot, that is over here, which indicates that the most areas have relatively low number of establishment and lower unemployment rate. Also we can see that there are few outliers with very high number of establishments over here, around 30, 35 to 40 and 45. So we can see that these are the outliers, and a wide range of unemployment rate is around 6 to 25. So here a high number of unemployment rates are there. That is why there's a lot of points which are clustered over here. We can also determine that there is a significant amount of variation in the unemployment rate for areas with similar number of establishments, particularly in the range of 10 to 12. So in the range of 10 to 20, I mean. And this also suggests that other factors beyond just the number of establishment also influence the unemployment rate. So this was about the scatter plot. Let's now go to the the radial plot. Let me see how we can analyze and what interesting observations can we make. So for the radial plot, let's choose an attribute called average weekly wage. So we can see that a beautifully radial chart is get plotted over here. We can see that if we hover over each bar, we can get to know the county name and the average weekly wage of the county. So the length of the bar represents the relative average weekly wage in each county or region, as I just told. uh, Counties with longer bars, like Santa Clara. So Santa Clara is around here. So San Diego is also San Francisco. Santa Clara is over here, and San Francisco and Alameda. They tend to have higher average weekly wage when compared to those of the shorter bars which are over here. So this could be like there could be a lot of reasons why this pattern could occur. So first one would be the geographical pattern. So we can deduce that there seems to be a geographical pattern in the average weekly wage, which means that the counties with average weekly wage, which has the highest average weekly wage, are generally clustered around the San Francisco, that is the Bay Area. uh, so areas like Santa Clara, Alameda, Marine, all these are clustered around the Bay Area, while counties further away from this region, they tend to have low low average wage. Also, we can see that the cost of living difference. So since these counties have higher weekly wage, so their cost of living is also high, whereas compared to those with low average weekly wage, you know uh, their standard of living or cost of living is also low. So these could be some of the observations which could be made from the scatter plot and radial chart. So
So this is all about our visual dashboard. Thank you so much.